Is this thing on?
Yes, I made sure.
I haven't done this in a while. I'm not sure what to.
Just say the thing.
I'm not sure how. I don't remember how to do this.
You say one thing.
I mean, what's my line? I'm forgetting. Line?
No, they're gone. Oh, Jaina, he needs his line.
I forgot my line. Hello and welcome to your weekly dose of mayhem, the only show coming at you from the overworld. Hey.
I don't condone that joke. I was not part of that joke at all.
We have a blue screen, and I'm going to do some drop comedy now.
Oh my god. It's the lab.
We are actually in just another different part of the lab.
Wow.
Than we were. Well, we're actually in the same part of the lab as season 1, just rotated 90 degrees, and not the same part as season 2.
Are you like a magician or something?
Yep.
Well, I guess that does it.
Reality bends to my will.
Anyways.
We're working on getting a real background, but it's not done yet, so in the meantime, we got Steve-O back.
Yeah, anybody in the chat or in the comments, scream at Jaina for not having the background done. Everybody needs to tell Jaina to get the background done.
No, wait.
What are you doing? I thought we had some, stuff to talk about that you were rushing me for.
We do have stuff to talk about, and we have very limited time because Harmon and I do not have the same study hall this year. So let's do this quick. As per usual, first episode of this series is going to be the first week of FTC. Howard, what do you think of the game? How about you give us a brief synopsis of the game for the folks at home? Hello, Grant.
It's like basketball if there were more balls and less baskets.
And 200% more ramp.
Yes.
Than basketball.
Where's the ramp in basketball?
There's no ramp in basketball, so that's why it's 200% more ramp.
Our next class is Calc BC. I don't know how percentages work. I'm terrified. 2 more ramps than basketball.
200% more ramp.
Yeah, it's a pretty interesting game.
I've been saying it for years, ladies and gentlemen. All I wanted is a shooting game for FTC. You can close that door. It's okay. I don't even know that kid's name. But yes, all we've wanted was a shooting game for FTC for years, and now we got it. I'm taking off my coat because it's hot. I have arms. Not anymore. Oh, he's gone. All right, well, we started. Kickoff was was 6 days ago.
Yep.
And we had teams from all around, Beam, Odin, being 2 of the teams who joined us for kickoff, and we watched the game, and there was a lot of oohs and ahs when it became obvious that it was a shooting game.
And Jaina screaming.
And Jaina going, shooting game! As per the title.
Yeah.
And we tried out, I'm going to give a brief synopsis of this. For more detail, check out the build thread, which is going to go up tonight on at Chief Delphi or at ftcopenalliance.org/teams/12736.
Wow, you actually remembered that.
I do.
Very nice.
I got that one. That's off the dome, too.
I can't do anything but remember it because I made it.
So check the build thread for more details on this, or check the episode of the FTCOA show, Season 2, Episode 1, which went out yesterday and features me.
And me, but I don't talk that much.
Hamid gives the open line synopsis. But what we did was we have been working with Mr. Burnett, one of our longtime mentors, just as long as I've been on this team, to get more creative, get those, what does Hyman's history say?
Get those brain cows milked. Yes.
We were getting those brain cows milked with Mr. Burnett in a lot of divergent, convergent, and then more divergent thinking.
Do you want to explain how that works, or should I?
You do it.
Okay, divergence, right? When you have a problem, right? What you want to do
like
first,
an FTC game.
Yes, you want to assemble a list of potential different ways to solve the problem. And what a lot of engineering teams do is they go, "Oh, that's a cool solution to this problem, but here's why it won't work," and then they throw it in the trash. Thank you for the visual aid. That's not what we want to do now, because if you throw them in the trash, sometimes they, it's like
They come back.
It's like if you got like a candy and it's like a little chocolate thing, and you open it and you eat it, and then you throw the wrapper in the trash. But there was a little bit of chocolate on the wrapper that you could have licked off, but you didn't.
Because you're a fool.
Yeah. Instead, you
And a litterer.
assemble all of your little wrappers into a wrapper pile, and then you make a machine to extract the chocolate all at once until you have enough for another piece of chocolate.
This metaphor's falling apart quick. Yes.
Anyways, you keep the ideas even if you know that they are somewhat flawed.
Write them down.
You write them down. You
List.
keep them in mind because they could influence your other ideas.
Up here.
That's divergence. Convergence is when you take the list and you make a choice. You make a decision about which thing you want to do.
That one.
And that choice is not
That
only
one.
informed by the one that you by the thing that you pick, but also all of the other things that you rejected. So you can get
Rejected.
you can get
You still have them, but you don't throw them away. But
they
you're
go
not
into
picking
the
them, so
they
you're
go into
rejecting
the
them.
chocolate machine.
Yes.
So
Exactly.
that's how you get to an idea that isn't just the first thing you had. It's the culmination of all of the ideas that you had.
And you can be more confident that it's the right idea.
Yeah.
Do you want me to explain how we did this at kickoff?
Absolutely.
How we did this at kickoff was we split up into groups of mixed teams. So a little bit of green team, a little bit of white team, a little bit of beam, a little bit of Odin, the whole shebang.
Mm-hmm.
We wrote down on our whiteboards all the different aspects of this game. Picking up a block, shooting a block, I guess they're called balls, shooting an artifact, picking up an artifact, shooting an artifact, whoa. And then the end game pack, those are kind of like the three big ones. And then you write down all the ways that you could rephrase that problem as a question.
As a question.
Slingshot to it, or slingshot shooter, or pitching machine shooter. Grabber or rolling intake. Stuff like that.
Yeah.
Is it even possible to go above the other robot as they showed in the review video? Then, after you do that for like 15 minutes, and an important point to note, which I'm not sure I've noted this yet as I'm explaining this, but you don't try to get a set number of ideas. You give yourself an amount of time. So you're not going off. If it takes you 15 minutes and you come up with 3 ideas, that's just as fine if it takes you 15 minutes to come up with 10,000 ideas.
Yeah. I would have trouble writing that down though.
Yes, you would run out of post-it notes quick.
Yeah.
But you write down all the different ways you could rephrase your problem as a question. Then, in your group, you pick a question. Then you diverge again, thinking of all the solutions for that question. And that's when you start thinking about robots. That's when you start talking about motors.
Yes.
That's when you start talking about
Mechanisms,
spacing, actuators, mechanical engineering,
things doing things.
programming, vision, Steve, and that's what you do.
Yes.
And that's what we did, and it worked great. It's yet to be seen how well it's going to work for this season.
No, it's gonna work.
I enjoyed
saw
it.
it to the future. We did it.
Oh, you went to the future?
Yeah, no, it happened.
I see. I thought this worked wonders, and I came out of kickoff with a much larger knowledge of the game and a lot more ideas on how to play it. Like originally, right after the video, I thought, oh, that pack is going to be impossible. And then I read the rules. And then I was rephrasing them as questions and creating answers to my question. I was like, no, I've got it. And we'll get to it. I mean, it wasn't my idea, but we got it.
Yeah, let's get into the CAD. How about that? Let's see what these ideas formed into. Let's do a little transition. Here we are in the CAD.
Oh, this is good. I actually need to pull this up on
Yes.
Firefox.
Firefox.
Oh, it's so far away. We have a much smaller monitor now. We're not using the TV. The green team robot is called Herkimer. And the white team robot is called the Archivist. By the way, I don't think we're going to get into the white team yet. I'm going to probably give them a week to develop their ideas a bit more.
Yes.
So let's start here.
I'm going to hold on. Can I just get that for a quick second?
You can have it.
This, we are too far up. Can I just say?
Oh, yes.
Way too far up.
Transition.
There we go.
There we go.
A little bit nicer. There we go. Oh, the mouse is lagging. Oh, good heavens. Where am I going?
You're there. You got this. Oh, this is going to be...
Okay, there you go.
All right, let's start here. Once again, we did 30 hours after kickoff.
Yes.
Check the build thread for in-depth analysis and watch the streams. They're on the channel. This is what we got after 30 hours. This was our main digital prototype. During 30 hours, we broke our router, so not a lot of physical prototypes happened. We're working on fixing that. We can talk about that a bit later, though. This was our main digital prototype after 30 hours. What? Okay.
I got it right here on my phone.
Thank you. This was our main digital prototype after 30 hours. As you can see, we got a nice rolling intake at the front, and we got this cool up and down. These are wheels which are slightly shorter than the block. The space is like I think 4.5 or so. So that when the ball comes in, the wheels get shifted up by the force of the block getting rolled under, and then they can go above it and then behind it to force it in. One problem with this is, let's see if Harmon can figure out what's wrong with this. Gear here. Mm-hmm. Gear here.
Yeah.
Driving this shaft, right?
Yeah.
Gear here. Shaft over on this side, right?
Yep.
Belted to here. Mm-hmm. 2 more gears.
Yeah.
What's the issue?
Not enough rubber bands.
No.
And also it's spinning the wrong way.
Yes. I'm gonna pull up the YouTube.
What's our recommendations gonna be like? Ooh, BattleBots.
Andy Mac. Hi, Andy. I think that's Andy. I don't actually know who that is. That might be Mac. Oh, look, we're live.
What, really?
Uh-oh. Oh, my mouse is lagging. Uh-oh. No, don't click on the live. No. My mouse is lagging.
Hold on, I got it.
Okay.
Sometimes you just gotta move it a little bit. There we go.
So, that was a original intake. The rollers on top. Oh, the computer's taking off.
The computer's taking off.
This was our original intake idea. And then we had we got some indexer motors back here, which were driven by the same motor, just a couple wheels. And the idea was that we could hold 3 blocks, or 3 balls. I'm going to keep calling them blocks just so Vex called them. We can hold 3 balls in here, 1 here, and then 2 in here, this space. And then this last wheel here would kick it up into this turret. And this is what we would use to shoot. And we'll talk a bit more about the turret later. However, this was what we did at 30 hours. This has already changed. And you can see that in what is now our new most viewed short.
34,000?
Uh-oh. Those are copyrighted. Uh-oh.
Is the audio on real quick? Hold on. Let me check if the audio's on.
Yes, all these shorts have pretty copyrighted music in them.
It should not be. It is not.
All right, we're good. We're good. We can play them.
All right.
So this is our new most viewed short at 34,000 views.
Hold on.
Please.
Hold on. Yeah, there we go.
All right. So this is our new intake idea. This is something that Josh and I came up with at 30 hours. Hi, Josh. This is something that I'm going to turn off the music because it's distracting me. This is something that Josh and I came up with at not 30 hours. At summer camp over the summer. It's a nice rubber band intake, and that is the intake from a summer camp robot, which we just put on a little 3D printed space intolerance testing rig that we have. And it works great. It's a lot simpler than the up and down one.
Yep.
Because the rubber bands do that motion, and then you don't have to move the whole shaft, and don't have to worry about gearing it or gearing it weird.
I mean, Josh seems to agree. Look at that.
Josh seems to agree.
Yeah. He loves it.
And then, again, we also changed the indexer. Instead of having wheels on top, we were like, what if we put rubber bands on the bottom? And those Vex V5 rubber bands, silicone rubber bands, and it works great as long as you have something on top of it. And then we broke it. So you see, this is with nothing on top, and the ball do not want to go forward. But as soon as you put even a little bit of pressure on top of it, those rubber bands are just pushing that ball along.
Because it rolls.
Because it rolls. And that will, that's the thumbnail. And that will go in this space here. This wheel, and I can actually show you that because we have it in 2D. This hasn't been turned into Crayola yet, but this is kind of what we're working with. So this is the rubber band intake here. And this is the 5-inch ball. You can see these are the 3 storage locations so that we can hold 3 of them. And this kind of thing down here, these are rubber bands. So it gets intook up here via rubber bands, and then indexed here via rubber bands, and then stored here, kicked up by this wheel into a turret and shooter up here. And the reason we can't store one of the balls up there is because we want to keep this wheel always spinning with a flywheel, or slightly spinning always with a flywheel, to avoid ramping up and ramp down.
So what about this turret? What's the deal with turrets?
We don't really have a
no, we got a short. We got a short though.
We do have a short. I forgot about the short.
Yeah.
Well, basically, the turret is we want the idea behind the turret was we wanted to be able to move the drivetrain around all we wanted. the intake and stuff, but we wanted to have the turret or the shooting mechanism of the robot to always point. What are you doing?
Trying to find the CAD again.
There's no CAD of the turret yet.
No, the Crayola CAD.
Oh, it's yeah, I got it. So if we can move the drivetrain all around all we want, and the turret can always stay pointed using cameras, math, and vision and programming that I don't understand. The turret can always stay pointed at the goal so that we can always shoot.
And now it's time for me to explain the programming and the math. So here is what we got for some turret tracking. So that's me, and that's an April tag right there. The camera right over here is looking at the April tag. And basically, you imagine, right? Like,
That's a Limelight 3A, by the way.
Yes.
It's
So
not we're not using that anymore, but that's what we used for this test.
Yeah. So what you imagine, right, is you see, like, if you're the Limelight, you look at this April tag and you go, this is sort of to the left of where I'm looking at it, right? In this frame of my vision, it's sort of to the left. So I'm going to move myself to the left until this tag is in the center. Then I'm going to stop moving. And it's the same thing if the tag is to the right. If the tag is to the right, me as the camera, I'm going to move to the right until I see it right in the center of my vision. And guess what happens when we program that in? When the tag is in the center of the Limelight's vision, the Limelight is pointed right at the tag, and, by extension, the goal. So it's a really simple algorithm, but in practice, it just locks on to the goal. No external input needed. As long as it sees the tag, it's locked onto it.
And then you do some more math and some physics, and if you have a shooter that can vary its angle, you can do some range equation and some Pythagorean theorem, and you can, and if you know the RPM that you're shooting at, you can tell the robot, at this RPM, angle the shooter at this angle to make it able to make sure that the ball goes in no matter where you are on the field. Now, we do have a shooter prototype, if Hamid would scroll down.
Hold on, I think it's going into recommended. Where's the shooter? Oh, here it is.
We do have a cool shooter prototype to show you.
I'm gonna move to where it. Yeah.
So this is again using those tolerance testers that we have. These were just couple wheels, and we shot one in there, and then 3 in a row.
Yep. Purple, green, green. That's not a thing. That's
Purple,
not
green,
right.
Purple, green, green. Yes, it is. Actually, no, it isn't.
It's purple, green, purple.
Well,
or purple, purple, green.
Yeah.
Anyways, yeah. So that's the rig here.
So yeah,
And
those numbers on top are wrong. Those are 3-inch anti-mark compliant wheels on the bottom, and there's on the shooter that worked. This one didn't work in the video. 3-inch anti-mark compliant wheels on the bottom, and then 2-inch anti-mark compliant wheels on the top.
Yes,
green.
And I'd like to make a shout out, if I can, to one of the FTC Open Alliance teams, Seattle Solvers, because if I pull them up, 1 second. Let's get a look at Seattle Solvers, because I know you were talking about the equations. That's the wrong link. I want CAD.
Have they already? Oh, if they've already done the equation.
They
have
have a little. I'm not sure exactly how it works, but I saw that they had.
I haven't actually looked at this in CAD, but you did show this to me.
Yeah, they have a feature script, seemingly. I don't actually know where. I think it might be in here. No, they have changed it now. It used to be different. I'm gonna see if it's probably not an intake. It might be in drivetrain.
Wow, they've made a lot of progress in
Yeah.
a couple weeks, a couple days.
That
So
is
that's
their
robot sign. It's in the build thread, is it not?
No, it is not in the build thread.
Well, what they had was they drew out the trajectory of the ball in CAD, and they did the math like that. So I don't think you can actually access the vision history.
It sucks. Well, you might have seen it for like a split second there, but they had a basically a 2D bot sketch with their design, and then a sketch of the goals, and they had a custom feature script of the trajectory of the ball. So I would assume, I don't actually know what they're doing, but I think they might be doing trajectory calculations in Onshape using feature script,
Which is pretty cool.
That's pretty cool, and I think I might want to learn how to do feature script so I can do that.
I'm not sure it's a feature script. It might just be them being able to manually control it with just by dragging points around it.
Yeah, it looked like a feature script. It was instanced like a feature script. It said ball trajectory 1, and there was an icon, so it feels like a feature script thing. So, because feature scripts have icons.
That's pretty neat.
But I'm gonna see if I can try and do that. Can you do feature scripts in like assemblies?
Yeah, well, maybe.
Okay.
I don't know. I'd have to look at
Because
it.
if you
I've never
could
used
do
one. I don't
that
think you can.
trajectory, but in 3D, that would be the coolest thing.
Yeah. There might be a way. I don't know how.
Yeah.
Let's transition.
Didn't do it.
No, I
You
gotta
click
select the other one.
There we go.
Transition. You're a normal cat this show.
Hello, Steve.
Hello, Steve. That's basically what we got right now, though. We got a design. Bye-bye. Are we running out of time?
Yes.
We are very much so running out of
We
time.
have
But that's pretty much.
AP Calculus BC in 5 minutes.
That's pretty much all we got, though, right?
Yup.
You saw basically the design. Rotor intake at the front using rubber bands. Indexer, kicker, handoff into a turret, and then the turret shoots. Drivetrain moves around. Turret always aiming at the goal, whatever it's called. It's got an actual name. And then when you hit the button, boop, shoot.
Oh, we didn't talk about the kickstand, did we?
That might have to be a story for another time. Basically, well, briefly, we're not going to show it. Briefly, to pack in at the end, kickstand so that your front two wheels are off the ground and your back two wheels are in the zone.
Yeah.
And you're supported by the square, and
Yeah.
you're only taking up a third to one half of the
Because
square.
it's not about if you're in the square, it's about if you're supported by the square. So we're going to kick ourselves up so our back wheels are no longer supporting the square.
We know it's time to go to class.
Being supported by the square, yes.
That's pretty much all we got. We
Yup.
got to go to class. The first episode always takes the longest to set up.
And we got to teach new people now because we're going to be gone soon.
So we got to go to calculus.
Thanks for watching.
We're shutting it down.
Oh my god, he's warping again.
We're out.